didn't we have a fine number of examples, especially for the ambiguous case? So I think we're really ready to move on. We understand this. We can apply the law of sines. You know, we're actually not leaving this yet. We're going to do one more session where we look at a general strategy. So anytime you see one of these problems that's eligible, okay, so here's the system. This is the same system that Mr. Schwartz has in your workbook. It's just I have put it kind of into a flow chart. As you're getting started, you should determine whether or not a triangle is possible. This is going to inform what you do later on. So you're in a ambiguous case. You can recognize that. That's a case where you have side-side angle. And we have been looking at those problems in this way. We've been putting alpha here. We're given this side, which is B, and this side, which is A. So there's our side-side angle. And we've been doing all our diagrams in that manner. In this lesson, we actually are going to switch that around a little bit. We'll still have angle side-side, but we maybe won't start with alpha. It's just a matter of reorienting yourself. It's not difficult. If the angle, this one here, is acute, then you're going to check to see if the sine of beta, and of course beta is the angle opposite B here. What we're wondering about is this angle over here. If the sine of beta is less than or equal to 1, we're going to answer yes and go this way. If the sine of beta is greater than 1, and you answer no, well, sine can't be greater than 1, so you say no, this is impossible, we don't have a triangle here. The other possibility is you look at this angle and you see that it's obtuse. So in that case, you're going to let's draw a picture of that. So this angle, alpha, is obtuse. Here we've got B. Here we've got A. If the opposite side, A, is longer than the adjacent side, B, you continue on. Alright, so let's look at the continuing on. First you find beta. Now you actually eventually, I've never, well, maybe once in our examples did I actually begin with arc sine. I think it might have been never. But you could begin with arc sine. You could say, okay, arc sine will give me beta. And what's going to go in is right here. What does this represent? This is the sine of beta. You can go ahead and figure out what the sine of beta is in the way we have been doing it rather than jumping right into this. Or if you're comfortable with this, just jump right into that. So we found beta. What else do we need to do? We need to figure out what gamma is. And we can do that using the sum of all angles. Then we can find C using our ratio. So this and this are going to equal the ratio. And another way, this, the more I look at it, I suppose it just makes it more confusing for you when I do this, but what is that? That is the law of sines ratio, right? B, the length of the side opposite beta times the ratio that we established with alpha and A. Okay, now you go ahead and you look at all three sides versus all three angles, and your longest side should be opposite your largest angle, your shortest side opposite your smallest. And if these things are true and you have an acute angle, if I should put it this way, if alpha was an acute angle, then you keep going because you need to find that second triangle. If the answer to this is no, well, you clearly have made a mistake. You need to go back and find what your mistake was. Let's go through an example. We've actually seen this example before, so this should be pretty easy for us. First, we'll draw that sketch. We have an alpha of 31 degrees. Let's draw that right there. We have B of 9, and we have A of 22. So the first thing we're going to do is determine if a triangle is possible. We do that by finding the sine of beta. Let's turn our calculator on, check our mode, make sure we're in degrees. Oops, in degrees. Now I'm ready. The sine of 31 degrees divided by the side opposite of 22 gives me 0.0234, so I have a ratio, I'll put it here, 0.0234 sine of beta divided by the opposite side equals my ratio, and my ratio is 0.0234. So sine of beta equals B times 0.0234 equals the length of the opposite side times the ratio. All right, turn this on. We're going to multiply this times the length of the opposite side, which is 9 times 9 So the sine of beta is 0.2107. Sine of beta is 0.2107. That's our sine of beta. And the question is it less than or equal to 1? Well, definitely less than 1. So we can continue. We'll find beta using arcsine. So we say arcsine of this ratio, that's our beta. So arcsine of this ratio here, 0.21067, gives us our beta of 12.16. We'll call it 12.2. 12.2, which means we need to find our gamma, right? We add to this alpha, which is 31. And then we're going to subtract that sum, or find the difference. From 180, so gamma is 136.8 degrees. 136.8 degrees. Okay. What is the situation I have here? I have, well, we'll look at it this way first. I have an acute angle. So there was the possibility, since my sine was less than 1, there was the possibility that I might have two triangles. However, look at this. 9 for my adjacent side and 22 for my opposite side. So let's find that situation here. 9 for my adjacent side, and 22 is clearly much greater than the height. My opposite side is much longer than my adjacent side, so I only am going to have one triangle. That's good. It's the sine of gamma over c equals 0.0234. So my c equals the sine of gamma, 0.6845 divided by this ratio, 0.0234. So I'm going to divide this by 0.0234. 29.3 is the length of C. 29.3. Now, does this make sense? I think it does. The longest side is opposite the longest or greatest angle. The smallest angle has the shortest side. So we're looking good. Now we'll do our next example. All right, first thing we're going to figure out is whether or not the sine of beta is less than 1 in order to determine whether a triangle is possible. what's my ratio here? Sine of 99 degrees divided by its opposite side, 9.2, for a ratio of 0.1074. Now I'm going to have the sine of beta over b or another way I can write this is the sine equals the opposite side, which is 5.5, times 0.1074. Here's our ratio, and we're going to say times 5.5. So the sine of beta is equal to 0.5905. So we clearly have a possible triangle. We haven't done our drawing. How could I be so negligent? Here we've got our alpha. Our B is 5.5. Alpha equals 99 degrees. And our opposite side is 9.2. So here we have this situation, looking at an alpha which is obtuse. We don't have A shorter than B, in fact just the opposite, which is good. We're going to be able to do this triangle. So now we need to figure out what beta is. Arcsine of this ratio, 0.5904658, far enough. 36.2 is our beta. 36.2. And our gamma, we're going to add 99 to that. And then we're going to find the difference with 180 degrees. 44.8 degrees. 44.8 degrees. Our C is going to be the sine of 44.8 degrees, sine 44.8 degrees divided by this ratio. Six point six. Let's say 6.6. Now, of course, we ask ourselves, does it make sense? The largest angle has the longest side. The smallest angle has the shortest side. So that's looking pretty good. I promised you we would mix things up a little bit. We're going to, in this case, instead of giving alpha and A, we're going to give beta and B. But my drawing, I'm going to keep my drawing just the same. I don't have to, but it just makes it a lot less confusing for me. All right, so that's a definite obtuse angle, isn't it? My B, which is the side opposite, is 28, and my A, which is the side adjacent, is 19. So I have this situation here. Obtuse. My opposite side is longer than my adjacent side, so I'm free to go. Let's figure out what this ratio is. I'm going to do the sine, whoops, turn it on, sine of 160 degrees divided by 28. So we have a ratio of 0.0122. 0.0122. That's our ratio. Our sine of alpha is related to its opposite side by the same ratio. I can say that our sine of alpha is equal to the length of its opposite side times the ratio of the sine of beta to its opposite side, 0.0122. Okay? So let's multiply that by 19, and that gives us the sine of alpha, 0.2321. Agreed? Now, we know what the ratio is, so we're going to do arc sine. We'll put that in to find out what our alpha is in this case. We just renamed things. We're going through the same procedure, just we've named things now a little differently because of what was given this. Arc sine, 0.2321. So alpha is 13.4 degrees. degrees. And my gamma, I use my 180. It's going to be so tiny. Oh my goodness, because I add 160, this big obtuse angle. I find the difference with 180. So I've got an angle of 6.6 for gamma. A wee little 6.6 degrees. All right, now I'm going to figure out what C is. How do we do that? We find the sine of 6.6 degrees, and we divide it by the ratio 0.0122. It's 9.4. That's our length, 9.4. Now we're going to see if this makes sense to us. The largest angle has the longest side, the smallest angle has the shortest side. So it certainly makes sense to us. Okay, let's do example 14 and see how this looks to us. We just have rearranged things. We're going to be working with this. All right, let's do our drawing. Now I'm going to call gamma this angle down here, which is an acute angle, 47 degrees, 13 minutes. It's good we're looking at that again. It's been so long. And here's our A, which is 1 foot 10 inches. We're not going to be able to work with that. We're going to have to let's convert it all into inches. And then our opposite side over here is a nice long one, 2 feet 2 inches, at least long relative to A. And that's a good thing, isn't it? Well, that means that the situation we are in, we've got an acute angle. We're in this situation here, where this is certainly longer than the height, and it is longer than the adjacent side. Let's go forward. The sine of gamma over C. Let's work it out. I can either put this in like this or convert it into decimal degrees and put it in. I think it'd be easier just to put it in as it stands. 47 second on apps gives me degree. 13 minutes. This time I go down to the minute symbol. Let's see if I can get the sine of gamma. Didn't have any problem at all. And you notice it's less than 1. Nope, that's good. Then I'm going to divide by how many inches do I have in 2 feet 2 inches? 26. So I have a ratio of 0.0282. 0.0282. The sine of alpha over A, which is 1 foot and 10 inches, or 22 inches, equals the same ratio. Sine of alpha equals 22 times times 22.6210. So alpha must be the arc sine of 0.6210. arcsine, 0.621. 38.4 degrees, 38.4. Now, we could keep going, but I think you've definitely got the hang of it. I'm going to do a little quick review here of the isosceles triangle. You learned this in your geometry class. The vertex angle is opposite the base, and on either side of the base you have your congruent angles. The legs are also congruent. That's our isosceles triangle. The bisector of this vertex angle is a perpendicular line, making right angles here, which bisects the base. Okay, that is something you want to remember here as we go forward. Okay, so when we actually do run into a situation where we have two triangles possible, when is that? That's when our opposite side is shorter than our adjacent side, but longer than the height. What do we do then? We go ahead through everything we did previously. We find the acute angle in our triangle, and then we find, okay, what about the obtuse version? And you remember how we did that. We used, we actually haven't done it by using our knowledge of isosceles triangles and straight angles. We could. What we've been doing is this way. We would find our reference angle, and then to find this next one, we would put the reference angle in the second quadrant, and we'd figure out what this obtuse angle was. There's so many ways to go about these things. So we're going to do example 13 again, and we're going to think about this other way of doing it, thinking about the isosceles triangle. Maybe this diagram is good. You can see here that what happens with, here's the acute version of beta, here's the obtuse, and they form an isosceles triangle. Okay, so maybe we'll do our drawing like that then. We are going to try this method of drawing the two possible triangles together. That way we'll get that little isosceles triangle, and we can use the supplement of B to know what B prime is. Let's start with this one. We have an alpha of 25 degrees, okay, and I don't know what this is, but an alpha of 25 degrees, an adjacent side of 14, an A of 11, and it's either going like this or this. This is our, right here is beta, and right here is B prime. This is our obtuse one, this is our acute. Let's go ahead and draw in our bisector and recognize that these are congruent. So B prime has to be the supplement of B. I think that really is a neat way to do it. We'll go ahead and get our ratio. Sine of 25 degrees divided by 11 gives us a ratio 0.0384. 0.0384. We're going to find the sine of B over 14 equals 0.0384. Or as we know, we could simply say the sine of B equals 14 times this ratio. So we've got the ratio sitting right here in our calculator, times 14, 0.537878. 0.537878. We're going to figure out what beta is using arcsine. And we put the ratio into arcsine to find the angle. Arcsine of 0.537878. 32.5. 32.5 degrees. I'm not going to figure gamma and C right now. You know how to do that. We just want to demonstrate how we use the isosceles triangle. So B prime is a supplement of B. Therefore, find the difference with 180 degrees, and the supplement is 147.5 degrees. 147.5 degrees. Well, that is a nice way to do it. We're going to demonstrate the same thing again. Over here, I'll leave what we did find in place. And we'll do the next one. We'll do our drawing, but first let me get the ratio since I've got my calculator right handy here. Sine 38 degrees divided by 13. 0.04736. 0.04736. That's my ratio. Let's do my drawing. I've got 38 degrees, so 38 for my given angle. I've got a B of 21. That's pretty long. And I've got A is 13. So I draw in my bisector. I recognize that these two angles are congruent and that this is beta and this is going to be beta prime, the supplement of beta. So I would go ahead and go through all those calculations. You can finish that up in class or ask me any questions and work on homework problem number 3.